This is Physics 241 Lab. Today we're going to do Lab 6, and we're going to cover Newton's second law, force equals mass times acceleration. We covered F equals ma earlier in Lab 5 in our friction lab, and we'll go into it in more depth in Lab 8, which is Atwood's machine. But in this lab, we're going to show that F equals ma graphically. What the lab consists of is we're going to have our track, and we're going to have a cart on it. We're going to place on it an accelerometer and a force sensor. And we're going to pull on the cart. And as you can tell, we'll be at some point weighing this material. We'll be with the accelerometer measuring the acceleration, and with the force sensor measuring the force. So we'll have all three components. And when we actually do the physical measurement, we're going to have 5 scenarios. We're going to have this cart, plus we're going to be adding some weight. Now, the two things we're going to do is when we measure it, we're going to measure it graphically. We're going to hook this setup up to our computer, to our Vernier software, and we're going to generate graphs. We're going to generate a force versus time graph, an acceleration versus time graph, and most importantly, a force versus acceleration graph. And that should be a straight line.
Okay, we don't. Okay.
And we're going to use the linear fit function of the Vernier software to get the slope of that line. And the slope of an F over A graph equals the mass. So the slope of this line is the mass. We're going to get that number from the graph, and we're going to compare it. That's the measured M. And now we're going to do a calculated M through weighing the masses. And these are our 5 scenarios. The cart and all the sensors weighs about 0.6 kilograms. And then we're going to add 1/10 of a kilogram, or 2/10, or half a kilogram, or a kilogram. And these will be the associated weights. When we looked at the graphs, the F over A slope, this was the mass. This was the measured mass. This is the mass calculated by the scale, and this is the mass determined by the graph. And we can compare 0.6 to 0.41, 0.7 to 0.54, 0.8 to 0.68, 1.1 to 0.98, and 1.6 kilograms to 1.53. So our percent error can range on a high of 31% to a low of 4%. So what our conclusions are from this lab are that we substantially validated F equals ma graphically. And as you can see by the error, the larger the weight, the less the error. Less room to make an error when you're working with a heavier material.